Welcome, I'm Bill Wake. We're working on a programming language called 10th, and we've been doing the compiler and interpreter. Lately, we've added a repeat until statement, and we tried a nested repeat until, and it seems like it's not working right. So we're going to look at what's involved with that. So I think identifying where the problem is, this is sort of a challenge when you're writing compiler-like things. So we have different possibilities. So one question is our test case right? Is our high-level code right? So I think I've got a version of it that we tried, but if not, it's something similar. Notice there's a repeat until in the middle. Repeat.1.1 minus dupe bang until, and then an outer one. So I'm trying to get the effect of 5, 4, 3, 2, 1, 4, 3, 2, 1, 3, 2, 1, 2, 1, 1. Okay, so sort of a triangular number list. But what we're getting, we seem to skip over the termination clause and just kind of produce more and more negative numbers. So it could be a problem there. I don't think so, but maybe. And then the second one is our compiler's translation right? So if I just take a piece from kind of the middle there, the first bang, there's bang, and then the until statement turns into jump if false, followed by an address, and then the add, and then another dupe, and so on. That's the stuff in our secondary, which is a list of routines to call with occasional extra data, like the jump if false has. And we looked at that yesterday at the end, kind of in the debugger, and it appears to be okay. I'm not saying it's not a zero chance that it's wrong, but I think it seems okay. And then the third question is the interpreter interpreting it right? So that jump if false, it takes the top data off the stack and it pops it off and looks at it and compares it to 0. And if it is 0, then it wants to jump, since it's jump if false and 0 is false. And we're doing that with load R VPC gets the contents of VPC. So we're expecting, like in that one above, the X1004 whatever, that's the value we see at PC. So we expect to load that value into the program counter and pick up from there. If the value is not 0, then we want to skip over that X1.10004, etc. We want our jump if false statement to proceed down to the add if it's a true. Okay, and the code we have is basically encoding that, and adding 8 to the program counter basically moves it forward one cell, and we're good. Okay, so what's our problem? Well, I don't know. I mean, we did go through the debugging on the produced code, and it looked okay. So I think maybe, and we've tried several variations on our input code. So I think let's look at what happens in the interpreter when jump if false gets executed. And that's in control here. Okay, jump if false. Evaluate the top of the stack, branch around the code if it's false. Well, that's not quite true, right? Branch to specified address if false. Okay, maybe that's a little more true. All right, data value on top of the stack comes in. VPC is a register pointing to the address following the jump if false word. We feel free to use X0 as a temp. The output, the original data is popped, so the stack's one smaller. The virtual program counter is either updated to move past the address value or jump to where it says. All right, that sounds like what I expect. All right, so we pop a value off the stack, compare it to 0. If it's equal to 0, we jump to skip if, which means false, which is when we should jump, and loading something new into the VPC is definitely a sort of jump. So that seems promising. If it's not 0, then it's a true value, and we're going to add VPC plus 8. So skip past the address we keep in there. I don't know. It looks okay to me. The only thing that gives me pause, and I kind of feel like I know the answer, but maybe I'm wrong on it. I'm assuming the virtual program counter points to the next instruction to execute. Okay, and so adding to it should skip the data value there and move to the next one. But more critically, this one should jump to the address we say. Okay, so now I haven't checked this. It required a lot of holding back, but let's go find. Well, I don't even know where to look for that. We want to find where the virtual program. I guess it's stack 2D. That's an interpreter. Start 2D. Okay, so, well, no. Okay, so my worry was, what if we did the increment after the call? Okay, but I think we're doing it here. So this is when we want to dispatch to something, we load the thing pointed to at the VPC, then we auto increment it by 8. So we've moved to the next instruction before we go doing any loading or calling. Okay, so that doesn't sound like it's going to have the error I was afraid of. All right. So my plan, well, I guess my plan is run lldb and let's break at the jump if false and see if we can make sense of it. Okay, so let's see, lldb, let's do it in REPL. Okay, so we'll break jump is false. Let's dump REPL.out just so we have the latest. Well, maybe I'll do a clear just to make that a little better. Okay. And then I'm going to run the REPL. Yeah, so let's run. And we'll do this in a definition because our repeat until needs that. Let's put 1 on the stack. Well, let's put 2 on the stack. Repeat dot 1 minus, so that's going to reduce it by 1 every time. And then so it's going to go from 2 to 1. We're going to duplicate it so we can test it. And if it's, say it goes from 2 to 1, then 1 gets duplicated, not 1 is 0, which is false, so until should continue looping. And then second time through, the stack is 1, dot prints 1, 1 minus, turns that into 0, duplicated 0, not 0 is 1 until his condition is now true, so it should stop. And we can print, and that should be a 0 at the end. Okay. All right, now we're not going to trigger a break yet, but this will. Okay, so what should happen is when we get to jump if false, we should stop at jump is false. Okay, good. All right, so let's look at that code again. Data pop and a compare. This really should be lowercase. My macros are uppercase. Okay. So load register X0. So this is our pop. Okay, so our stack, the system stack grows down and our stack grows up. So it's decreasing by 8 and pulling the value out at that location. Okay, so that's our pop. we're going to compare to 0, and we expect that to fail. So we'll just do a little bit of step. All right, so there's the compare. All right, now we expect x0 to be 1. Hmm. Well, when I say we, I meant me. I would have thought x0 would be, it's the top of the stack. I would have thought we had a 1 there. Oh, right, right, right. You're right. Bang has already been called. Okay. So it is false. All right. So the EQ should be true and it should take the jump, right? Okay. Keep me straight. Okay. So now 3530. Okay. So we did take the jump. All right. Let's look at X20. Okay. And then let's do a mem read minus C100. This 67D0. Okay, A67A0. I guess we could try and find it over here, but no, that's not going to be right. Let's mem read minus C100 OX1 4 zeros 67A0. That is 4330. Okay, that sounds no. All right, so X20 points to that 67A0. All right, I guess I should read, oh, there's 67A0. Is that? $43.30 is out of range, so, So what about 6710? Let's go back a little. 6710 is 3740. Is that a method? $3738. 40 is N2D. Okay. Well, we're seeing something that sounds plausible. Okay, so this one is 6710 is end 2D. I guess that's this one that counts. This chunk that I've got highlighted, that's part of our secondary. So the last thing in our secondary is N2D always. The previous line, I think, is a dot, 4330, right? Based on what we typed. Yeah, should be a dot before N2D. So 4330 should be our print. Okay. And then 67A0 is our print. That's our print inside the loop. Okay, so I think this is dot. And then it should be 1 minus duplicate bang, and then until. And then back to 67A0 is the target we're looking at here. Okay, I think that seems right-ish. Okay, so X20 is pointing to 67D0, and we're gonna, if we take that jump, if we execute the instruction up here, we expect to go to 67A0 next. Okay, so I'm gonna step and expect X20 to be 67A0. Okay, so that's sending us back to the print. Okay, so we're in, man, I don't remember how to show stacks, but we're in jump if false, but the parent call is start 2D. So I'm going to step again. We'll take the return, and I think we're in start 2D. Okay, that seems reasonable. Okay, and then start 2D branches back to the top. Well, that's definitely what we saw here. So branch L interpreter loop should come back up here. All right, and then let's step again. Okay, we want to make sure that 67A0 gets called. So let's find our print. Print is dot print. Okay. So we can break in dot print. Okay. But now we're at the top of that interpreter loop. So we're going to load X20. So let's get everybody's numbers out here. Reg read X0, reg read X20. 67A0. Okay. And we remember 67A0 here had a dot and so on. I think this is 1. Okay, so we'd expect if we step, it should change X0 to the contents of 67A0 and add 8. Okay, let's see, X0, contents of this is 4330, and X20 should be A8. Okay, good. All right, now I'm going to get the contents of X0. Okay, so let's do mem read minus C100, and we'll look at this. Okay, so 374C, and that is dot print. Okay, and then this should go to dot print. Huh. Well, that seems okay. We branched backwards to where we said we should, and all's right with the world. Well, we've inspected our tiny application, we checked our node contents, and we verified the interpreter, so we're all set, right? Okay, I'm just going to continue. Jump if false again, dot print again, and there. I think our first one was printed there. Well, let's look at our code here. Okay, so 5 repeat. The other way I know to do this is to do it on a page. Well, let's add a slide blank. We'll put this up top. Okay, and on the page, we just keep track of our stack. Okay, so 5 pushes 5 on the stack. Repeat does nothing, dot does nothing, 1 pushes 1 on the stack. Then we then we subtract. That leaves 4 on the stack. Duplicate. Okay, so that gets us up to repeat. Now we go into repeat and we print 4. Push a 1 on the stack. Subtract and dupe. And not true is false. Okay, until says jump if false. Well, it is false, so we go back to the repeat. That consumes our 0. Okay. We're back to the inner repeat at this point with 4 and 3. Okay, just repeat that, I guess. All right. In the inner repeat, we print 3, we push 1, we subtract, we dupe, we bang. Okay. Then we're going to continue. Well, is it true? No, it's false. So we're going to loop around to our inner loop again, consuming the 0. Okay. I don't know. I mean, this seems like we're doing what we should be doing. Well, I don't know. What do you think? Where should we try and do something? The other thing I thought of doing, I mentioned yesterday, we could interpret here this main loop. We could, well, where it got to, this loop, we could stop at this point and we know where we're going to execute. We could dump the stack right before we did every step and see what's on there. All right, I'm gonna want to explore. All right, my trickiness here is let's write a minimalist repeat loop, and all we're gonna do is Boolean not until, and then print. Okay, so I don't have it. It only works with whatever's on the stack, so we can do that. Can you add a word that prints the size of the VSP or the control stack? Yeah. Let's do something like that. Well, the control stack is not relevant, right? Because at runtime, because the control stack is used to create the secondary, but the interpreter is what's going to run there. Yeah. So anyway, my theory on this, I'm going to try this real quick, and then we'll put in a new word. Okay. So if I say zero not repeat, sorry, if I say one repeat, one zot, that pushes one in the stack. The repeat negates it. Should be a zero. Well, let's start with zero then. Zero zot. Pushes zero on the stack. Repeat not. That says true. Turns it into a true until and then stops. Okay. I don't think there should be any problem with this. It should just print one. Well, continue, and print zero. And let's try one zot. Prints a zero. Well, I guess it always had to be zero to get out. No, that seems wrong. Oh, yeah, that seems, I think, okay, let's set this aside. I like your idea that we'll put in a debugging word. Okay, so, and I'm just going to be, I'm just going to stick it in control for now. Okay. What do we got? I think it is. Yeah, that's why I was getting zero there, because I never did a dupe before the other thing. So, but I think printing the size of the stack makes sense to me. This is data size, data stack size. And he's going to have to do the prologue. And if I use that in here, standard prologue, standard epilogue, and end. Okay. And what's he going to do? Well, actually, this actually sounds kind of like a useful thing. If we just count the stack, that seems like useful to know, because you could do something that goes until you get to the end of the stack. So let's put it in there, but I am going to be cheesy and not test it. Okay. This is count data. And for us, the VSP, I'm going to fix this comment a little. VSP register points to top of stack. That's not really right, is it? Let's go to a init stack. He points to the next free word. Okay. And then VSP increased. Okay. So for us, let's do a load address. X0 gets this. And then the the VSP. So if we take let's make X0 no. Well, let's make X0 equals VSP minus X0. Okay, so this is the the current pointer minus the original pointer should give us some sense of the size of this thing. So when we start, that value will be equal. And then we got to divide. And I'm going to look at our arithmetic one to make sure I know how to divide. SDiv. Okay. Back here, SDiv. I don't know if I can do this with an immediate. Okay. But okay. Yeah. So, yeah. Can I do a right shift on a subtract instruction? I don't think I can. Right shift apply to a register. I don't think that's quite what we're after. Well, I think this will do it. All right. And then in main, we need a word for it. Maybe just pound. Count data. Yeah, we know it's an unsigned, so we could just do a right shift. But I think this will be okay. All right. And no, we can't. Okay. Let's go find that right shift instruction. Shift immediate. Logical. Well, I suppose it's really arithmetic shift right. If it had a 1 on the front. I mean, I don't think our space can be that big, really, but okay. ASR, XD, XN shift. Okay, good enough. X0 equals X0 shifted by 8. Post, oh yeah, I gotta make it global. Okay, this should be 0. Dot. Okay. 10 pound dot. Oh, you're right. Yeah. Well, let's do it this way. Okay, so pound dot should be 0. 1 pound dot should be 1. 2, yeah, because we popped that off, or we pushed that on. Okay. We made pound sign push and answer on, so we've already got the size was 0. We pushed it on, printed it. A value 1 we pushed on, and then pound says, okay, you got a 0 and a 1 on there. Value is 2, but I'll push it on the stack. It might be. It might make sense to make it print instead of just count. But we can always do. Well, no. Yeah, let's make it not do that. Let's just make it print. It's going to be more of a debugging thing for us. Okay, so let's move stack count. Well, load address x0 is stack count label. Let's do this first. Okay, and then this. Print num. Did I make those lowercase? Just print and print string. Okay. Okay, pound should just print 0. A little ugly, but livable. Okay, 1, 2, 3. Pound should print 3. Okay. Yeah, it might be nice. Oh, something failed. Oh, oh. Maybe we haven't verified that well enough. Let's run it first. Pound, 1, 2, 3, pound. Cool. All right, that's a nice little helper for us. Okay. Now, what's going on with this failure? We were off by 8 and 16, as I recall. I guess maybe I should look more at that. That test is control test. Okay, we set up a secondary pointer. Let's make sure that's big enough. 16 words. Yeah, that's probably big enough. Okay, set up that, initialize the control stack, make x28 be the control stack. I'm not sure why. Oh, okay, yeah, we'll check where it's backwards started. All right. We push a 1 into the secondary space. Okay, we call repeat. So this is all simulating compiling. Then we move a 2 into the space, and the address for repeat should be secondary space plus 8. Okay. Then we store x0 there and increment again. Okay, another repeat, and the address should be space plus 16. Yes, I believe that. Okay, then we generate until and until. So we should see 0, 8, 16. Next one's 24. Slot 24 should have the address of the jump if false. That passes. Slot. Okay, X0 is test secondary area. Slot 32 should have the word this is the inner repeat, so it should be this plus 16. All right. And what did it get? Expected 600 plus 16. So it's like our target address. Well, presumably 600 is the start of our thing. And we only pushed. Okay. I think what we'll check after the repeat, let's look at our control stack. All right, and where does that thing live? Probably on control. All right. Okay, and it's not a global, but it's not an L variable either, so we can set can do a search for it, I think. But let's maybe put it global. So I think global makes it use that when it's printing the value. We can try an experiment, but I think the debugger, it would get us there, but it wouldn't. It would probably put it something else plus something. But I think if it's got a global, it knows it's a real beacon point, if you will. Okay, but we'll make it global for the moment. So I think we could come into our test, control test, and if we look here, let's make sure the storage and repeat is putting the right thing in the control stack and it's in the right area. Okay, so control stack. Whoops. Okay, we got 20 words. Initialize it. We got a variable control stack. And it points to control stack. Okay, and then repeat. Oh, that's our problem. Secondary space is not right. Is that? Oh no, that should be okay. The secondary space should be where we're about to write into the secondary space. So we write that word in as the starting point. Okay. And then let's look at control push. And that was in assembly. Not sure it's the right place, but okay. So store register into control stack add 8. And data push is store register to VSP add 8. Okay, so that seems consistent, if nothing else. All right. Add an assert after the repeats. Yeah. So I guess we know control stack. What do you want to assert? That are we after the value of control stack or the contents of the stack? I mean, it might. We could print that. That'd be kind of interesting. Move x0 gets control stack. BL print and then same thing after this. Actually, unnesting them might be good. And then where's NL? IO. And now prints a new line. We can stick that in there too. Okay, we'll augment the test a little bit. This will print the contents of control stack, but we're not peeking at the control stack. Yeah, let's see if there's something weird in how it moves. Okay, so this is control tests. Oops. Undefined symbol for architecture start. Oh, control tests needs it's going to need IO. Where's my make file? Okay, so 880, 888. So it pushes, is just pushed. It pushes again. And then, yeah. So, I mean, it seems like it's pushing stuff in the right order. We're not seeing the contents. We're seeing the addresses of the control stacks, memory addresses. But it should start on 72. And then after the first repeat, it goes to 80. then it goes to 88, then it goes to 80, then it goes to 72. So I think it's the nesting appears to be okay. We could let's modify to print let's print the contents of those cells. That's a little trickier. Okay, we got the control stack. Let's do add x0 equals control stack minus 8. I guess that's sub. And then load x0 contents of x0. I think given that it was decrementing correctly, we're going to see those values the right way. Okay. So this should be the contents now. 434485912 is the outer one. Is my expectation wrong? I don't know how it's off 16 on one and 8 on the other. Well, I guess if I'm off 8 on each, then that would explain it. So, okay, that's not insane. But it also doesn't match my expectations. Okay, so the secondary space so x28, oh no, x28 is control stack. Okay, so secondary space is L-test secondary area, and we're going to store a 1 there, 196. We're going to store something at secondary space, then increment it. And then in 206, we store 2 in secondary space and increment it. So the stuff that's stored should be at secondary space. Okay. And then my expectations, x0 is secondary area, x0 offset by 32. I don't know. Is repeat the one that's doing this? Is he getting it wrong? Okay, the 32 here says we're at the 5th word, 4 times 8 plus the 0 word. Okay, so the 5th word of x1, x0 equals... Okay, so x0 is the contents of the 5th word. x1 gets x0. Well, no, something's weird. Okay, x0 is L-test secondary area. Okay. But then when we do loader, I don't know, I feel like I'm grabbing the wrong thing. Loader x0 from x032 gets the value in the 5th slot. Okay. Then we move that into x0. Value in the 5th slot. Then we move x1 equals x0. Well, that doesn't sound... No, that assertion is not right. me do this like this. I don't know if that's better or worse, but load x1 secondary strat. Okay, so the first one should be here. This address, space plus 16. So secondary test space plus 16. That I think is the right address. Then same thing down here. Okay, so no, this is okay, and then go back to the second slot. It should be that plus 8. Okay. I think that's the correct test, but I think it's also that's what it's doing. Yeah. Ugh. Okay. All right. I don't know what we're thinking. What seems wrong here? All right, I'm going to take out these prints because I think everything that we're seeing looks okay, including the stuff that's coming out. Yeah. It passes. Why doesn't it work? So, I don't know. This seems to tell me that our. It looks to me like our code is generated correctly. The code we generated is the code we expected to generate, I guess. I should say it that way. All right. Are we green at this point? I think we are. Okay. Now, I'm trying to think how the jump if false could be going wrong on the nested case. But our nested thing, right, the space plus 16 showed up here first for the innermost, and then the space plus 8 showed up for the outermost. So that seems correct. And we keep tracing through our code, and it seems good too. I don't know. Should we? I guess, like, what do we think is the problem? Is it a stack problem, or is it? I mean, our choices at runtime, right? Either we think we're calling the right addresses. Now, I don't think we stepped through the add x, VPC plus 8 case. But I don't think the data stack's going to tell us anything. All right, let's run. I don't know. Let's take this example and make sure we think it's correct. But that's what we did with our trace a minute ago. So let's see. I got to put in a function. let's get this function. If I repeat, one dupe, repeat, and then at the end we could put a plus or something. We think we're getting to a 0 there. Plus. Okay, so if I take this and I define zot as that, semicolon, and I run 179,000 before I can even click. Whoops. I gotta grab that thing. I must have a nice generous buffer on that. 5, 4, 3, 2, 1, 4, 3, 2, 1, 3, 2, 1, 2, 1, 1, 0, minus 1, minus 2. Okay, what happens when, let's say we did 1 here, then dot 1 is 0. That's what's going on. This is bad code on this side, I think. Oh my gosh, maybe. Okay, if we did 1, repeat, dot 1 minus, that pushes 0. We got a 0 on the stack at this point. Duplicate it. Oh, okay, so I got a 0 on the stack. Repeat, subtract 1. There's my minus 1. Yeah, it's the inner loop. So when the outer loop gets to 0, so if we started at 1, we'd be at 0 here, duplicated, and it's going to say, okay, take 1 from that and keep going until you're 0. So I guess if I waited long enough, I'd get a wrap around my 64-bit counter and hit a 0. It is our code. Oh gosh. How can I make this not? Well, maybe what we need is an if statement, right? I mean, that would help us there. Okay. Let's try instead of duplicating, let's just always print one element. So I think we'll change that dupe to a 1 and always print 1. And then when we get to the end, the 1 will do its thing and then exit with 0, and then the second dupe will duplicate a 0, bang, 0 is 1, true, should stop. Okay. Yeah, less than or something would help. Yeah, off by 1. All right, let me try that. So make REPL, and then, well, I'll change this to 1 now, and then change it back. Okay, so define Zing as all this, semicolon. All right, now I expect Zing to print 5, 1, 4, 1, 3, 1, 2, 1, and then stop. It might print a 0 somewhere. Yep, 5, 1, 4, 1, 3, 1, 2, 1, 1, 1, stop. Yeah, okay, so our nested repeat did work in this case, but my calculations of forgetting that I had a repeat loop with a 0 starting value is not going to work. Okay, so I think we can define another one. Then bar is 0 repeat dot 1 minus dupe bang until semicolon is going to go forever when I call it. Bar. Yep. Okay. Ah. Oy. Okay, well, we have our little debugging thing, but that didn't help us. The only one that might have helped there, if we'd caught it, I can't do that. I'll just paste. At one point, we printed dot before duplicating or after duplicating or something, and I thought, well, if we would have seen a 0 there in front of our repeat, and that sounds problematic. So I think we must not have done it that way, but we did put extra dots in there at one point, and maybe we had the 0 and I just didn't twig onto it. But yeah, after after an hour of validating, it's like, yes, the problem is our code in our new language was not good. Okay, well, I guess. One. All right. So I think we're ready to move on. I guess I'm happy about this. We did actually fix a problem though, because the expectations on this thing were wrong, so that's a good thing. But I think otherwise, okay, I don't need this page anymore. Delete. And we got a debugging print thing out of it, I guess, too. All right, we don't need you. Okay, so what's our plan here? All right, verify nested control structures work. I would say we did that. I did run a second loop with a constant in front, and that did work, so I'll call that good. But nested repeat until, okay. And we did that kind of manually checking that the stack got the right values, and the control stack, I should say. We checked that the generated code seemed to be right. We checked walking through jump if false and everything. So, I mean, I think we've done a fair bit there. We didn't check stack overflow or underflow. Okay. But it is, yeah, it is annoying. All right. Well, I would say let's work on these relationals. Yeah, let's just work on straightforward verbs or keyword, whatever you want to call them, words, I guess we should say, in our language. Yeah, and then I don't know if we'll finish those in an hour and a half, but then we'll start on if, else, and if. I don't think we're going to do for next just yet, but let's go ahead. All right, so I think, did I pull out relational? I did. All right, because we had NEQ already, because we needed that to test our recursion. Oh, let me go back to control. I'm going to take this meta word off, or the global off, rather. Okay. So I think we can close tabs to the right. Okay. And I think the pattern of this, well, in a sense, each one gets 2 tests because we want to check both directions on it or something. We got NEQ, and the function we're calling is NEQ. So values differ. Is the data stuff. I'm trying to think how to make a macro for this. Um, okay, let's do it. Um, so I think this is a variable because that tells us which values we're getting. Data. We'll start with data. Let's just always check that one, and then some other value in there, and the function, and true we want to check this way. Okay, and then false um, checks for zero, but we have the same data thing. Okay, so um, let's copy this macro test relation, and it's going to have a value for a value. Well, it's going to have a function value for a, b, and expected. And okay, a. Well, this is making it harder, isn't it? Let's just put the data in the data. Okay. So data plus 8. Let's do. What is ADR VPC data? What's ADR? Greater, exact, and less. Yeah, so I think if we say, here's the function, here's the first data value, here's the second data value, and here's the expected result, I think we cover all the cases we can do. Okay, I'm gonna make. I don't know. It shouldn't care the way it is now. This should still pass. Let's make sure that's true. This is relation test dot out. Relational. What line are you complaining about? Oh, I see. That's why they were in here because you got the relative. It's a relative load. So even if it's we don't have to do load address that way. All right, but I think I want to. Um, well, that's not being called, so I don't think that one should matter. Let's do a load address. Address x0. I don't know why I'm using VPC there. That just seems weird. Okay. Maybe we were using it as a temp variable, that register number or something. But let's load lldata. And then load x0 as contents of x0. Okay, because it's the address of lldata. And then this one, lldata plus 8. Okay, we'll push that. And then I think the rest works the same. Now what did I do here? We pushed twice. Okay, make sure these pass. Failed. X0 equals 1, x1 equals 0. Did I... Oh, this one had the same value twice. Before. No. Okay, we want the same value. Oh. Now I'm questioning this one. X0, x0 plus 8. Okay. Oh, man. All right, we're loading L data into X0. We load whatever's there at its value and push it, and then we load address X0 L data and we load what value there is. Why are those values not the same? I don't know if it's just easier to bounce in. The original was ADR VPC L data. ADR VPC L data. VPC and then push. Underscore push. Oh, we're calling our numeric routine. That seems like the hard way. I mean, if X0 contains the value, shouldn't we just be able to do data push X0, I think. This is test setup, but that seems the right thing. Okay, true if values differ. And then relation. Okay. Oh, golly. Okay. So this thing, well, we're going to do the same thing here. We don't need that. But I think even that is not needed. I think all we need to do is move X0 gets A, backslash A. That's some hard-coded value, and we're going to push it. And then this one is X0 gets B, hard value valid, push. Okay, so we're going to load A and B on the stack. All right, we got stack pointer set and a little test area. Okay, and then run any queue, which is really function. Well, let's call it relop. Pretty normal compiler abbreviation, relational operator. Okay. And then this is really just expected. Okay. And now I'll test this one with these same tests. Test relation. Well, the test name is relation test. Well, maybe I should put the name. Okay. So test relation, any queue, true if values different. I'll change it slightly. Okay, and the value in A was 142 and 58. Sorry, the function is any queue 142, 58 not equal. That's true. Okay. Slightly different name, 142, 142, and 0. Okay. All 4 tests should pass. Whoops. Gotta put them in there. How annoying. Okay, I think we're good. These can come out. Okay. Well, what our relations are. We can almost use that even for these unary ones. It just pushes 2 values, but we're making the call. Well, let's move these to the end. Okay, let's do equals. That's EQ 142, 142, and 1. Okay. Those tests failed because we don't have an EQ. We don't have these in this file. Should fail. Gotta call the tests. Okay, failed. We don't even push stuff on the stack. So yeah, there. Yeah, add the tests. Good advice. I really wish our macro could do it. I don't know if there's a. Yeah, I just don't have a good way. If we had separate text sections, I could do it, but I don't have that in this assembler. Okay, let's make it work. Well, these are going to be very similar, aren't they? Pop AB x1 x0, compare x or x1. This is EQ, I believe, and push. All right, now C144. I don't know, does preview let me do bookmarks? Equal EQ 0. Yeah, I guess that's what we want. All right. Should both pass. Good. And let's edit to main. Less than, I guess, double equals and not equal. Bang. Okay. Good. Okay. All right. True if the value is less 142 to 143. False if they're equal. False if the value is greater. Okay. And we need LT. Well, I think we're to the point we can say we need a macro for this too. Maybe it's even name condition. Name, we pop the two values, compare them, set based on condition, return. Okay. I don't know, do I want to do this? Oh, I didn't add LT. Okay. Let's check that condition. LT signed less than. Yeah, that's what we want. Didn't add my tests again. Okay, yeah. We can take out that other one. This is, I'm going to say rel up binary. Well, maybe binary rel up. Okay. True if the value is less than, yes. True if the values are equal. And false if the value is greater. Not sure the best way to get these in there. Oh, that might be good. I don't know how I would loop over it though. I mean, I could walk through it if I knew where it was, but I'd have to. Hmm. Well, I don't know. I wonder if there's. Let's look at our assembler. Yeah, this. So you have. I don't think you have one that depends though. Let's see. Align app. So you have com. So if you come on. Com says if you have defined the same memory area in two different files, then when you link them, don't treat them as separate things. Just smash them together, overlay them on each other, and if one's bigger, take the bigger. Okay, and this is Fortran common area. So Fortran, you can specify common areas between files, and then they get overlaid to each other. But what we want is something that more puts them after the other. Extern, not really. Global just makes it there. Yeah, I don't think there's a mechanism. IRP. That's sort of a macro thing. LCOM. Yeah. Yeah, we don't have section in ours, unfortunately. Yeah, no, I would like something. I mean, we've done enough of this. I mean, I make this mistake all the time. Yeah, I was wondering like symbol table stuff, but I don't think there's a mechanism to get names back from that. And there's no like global counter we can use. I mean, like yeah, you can't define a variable and then add to it or anything like that. If you could, we could probably fake up something. Yeah, no, I don't think there's a mechanism. I miss this though. I worked for Digital years ago, and they used Bliss, which was maybe you might call it C-like, but it was kind of a lower level down. But the thing it had was great. Was it had these macros that could build very complex data structures at compile time for you, and this kind of thing would be right up its alley. You know, just link something in like that. Okay, but we don't have it. All right, I'm going to make LEB the same as LT just to show the failure. Should fail. Yep. Oh, LE true if value is equal. LE true if values equal. Did I not put an equal value? LE true if values equal. I got a 0. Okay. Well, I see we're late for our break already. So let's take a break. We'll come back and figure out what's going on with LE that I'm not calling. Okay. Anyway, let's take that break and see you in 3 or 4 minutes. Welcome back. All right, let's just let's see. Is that supposed to be passing with that fix? I didn't run it yet. Okay. And we got less and less. Okay, let's get greater than in here. Greater than or equal. Okay, greater than true if value. This is false. So I'll take a little bigger stack here. If false, if the value is less, that's true. It's false if the values are equal, and it's true if the value is greater. And then GE is false if the value is less, true if they're equal, and true if greater. All right, and we don't have those two defined. Okay, I'm going to leave them wrong for a moment here. Make sure we get some failing tests out of this. Oh, if I put the tests in, golly. Do I have a multi-line editing mode in Xcode? Split selection by lines. I don't know what that means. Okay, now I should get some failing tests. Lots of them, all about greater and greater and greater. Okay. These have the right function call, but these, oh, option drag, okay. This should be GE and, oops, GE. Check our table. GT E signed greater equal, GT signed greater than. Okay. Yeah. Okay, good to know. Thank you. Okay, and let's get these things all in main. 3, 4, 5, 6 of them, right? Not equal NEQ, LT less than or equal LE greater GT. Okay, that sounds right. Okay, so 1, 2 greater dot should be false. 2, 1 greater dot. 1, 2 less than. 2, 1. All right, 1, 2 less or equal, yes. 1, 2 greater or equal, no. Okay. Okay, we haven't done these two yet. Now, the funny thing is we can use the same test setup. It's just the second value gets ignored. Well, so we got LT0. I guess I should take all three, right? Okay, LT0 if value less than 0. -1 is less than 0, so that's true. I don't know. I'm almost tempted to change this to be like when. LT0 when value less. Well, this is negative. LT0 when value negative is 1. LT0 when value 0. And I'm letting the value on the right tell the expected value because I found it hard to keep these up to date and haven't gone through them to be sure I'm right. Yeah, it looks like I've got them all consistent, but I think this will be a better approach. Minus 1, 0 is 0. Okay, and then LT0. This is a unary relational operator. Name, condition. Well, that's not so easy to say. Well, no, maybe it's okay. Okay, and I'm not relop. LT0, and the condition is, I'm going to say GT because that's definitely wrong, and less than 0. So I'm trying to get this wrong and get this right. All right, let's test our little theory here. Oh no. Okay. Huh. Interesting. All right. That's much nicer. -0. Okay. Should see some failing tests. Not quite that failing. X1. Oh, that doesn't go in here. Oh, wait. I just missed a comma, is all. Yeah, that's the function being tested. Okay, yeah, that should be okay. All right, LT0 randomly passed 1, but not. Yeah, I need to compare with 0. Yeah, I just threw in something to get a failure. Let's see. And so implementation-wise, I think you're right. This should be compared to 0. And then the condition, well, this one should be less than. Okay, so pop a value, compare it to 0, set it based on the condition. Yeah, that actually seems like it should work. One value negative. LT1 value negative. LT0 minus 1. That should be passing. Signed less than. Am I not getting the... Oh, I don't get the macro expansion. Okay. Did I name everything right? LT0, LT0 consistently. LT condition is LT. Name, condition, description. KC set X0 based on condition. I don't know if I... Is minus 1 not happy? It's the first... well, that's a darn good question. Oh, yeah. Yeah, you're right. I'm doing the wrong one. Okay, which tells me I'm going to make a new macro. Even if I call this one. Move X0/B. While in macro instruction. Oh, I don't want /B. Okay, that's better. Good. Well, let's add it to main too while we're here. False. False. 1 negated less than 0. True. Good. Okay. Okay, EQ01 value negative. -1 should give us a 0. 0 should give us a 1. 1 should give us a 0. Okay. This is bad. Oh, wait a minute. Oh, this is the condition. Sorry. Okay, I should get some failures that are not syntax errors. Good. EQ and value negative is good. And the relationship is EQ. Should pass. REPL should know how it works. Okay. Okay. Okay, and I don't know why, but stack ones are kind of my favorite. Just, I don't know. They seem so exotic. All right, so we don't need this one anymore. We need stack. No, what? Wait a minute. Okay. Oh, sorry. Test 1 equals 0 again. I put a space, so I just pushed a stack. Okay. 1 equals 0. That's going to be an easy one to mistype, isn't it? Okay. All right. What do we need first? Pop. Now, these may be... we might have to make these tests individual because each one of them is just kind of a weird little combination of stuff. So let's put a couple things on the stack. Call pop. VSP should be test stack plus 8 because there should be one thing left on it. And I'll push stack. And the value we expect on it is 21. So we're looking forward from the test stack. That should be containing the first entry 21. At one point we had 17 on, but 17 should be back there. And we should be pointing to a test stack plus 8. All right, and pop, I don't think we put one in here. No. Pop. Let's just do nothing. That should fail. Oops. Oh, I type make. Okay. Yeah, no wonder. All right, and these are stack tests. Where's pop? I didn't write the test. Okay. Right. So the pointer is off. All right. So it didn't really pop. We've got the right stuff in the cell because it's just sitting there. We didn't destroy it. Yeah, no. But the stack pointer's in the wrong place because it's still got 2 items in it. So that's good. We tested both things. All right. Now we need to do some popping. Okay, well, I think this is about the easiest one we're going to get. You just need to do data pop. We specify register, but we're going to ignore it. That should be all there is. Okay. And let's add it to main. Don't know if we have stack ones. Well, okay. I'll use our proper lowercase name. All right, now swap. Okay, so swap. Oh, I didn't put a comment on that thing here. Oh, no, I think we have a data push AB, don't we? Well, no. Okay. He might be handy. Yeah, I don't know. Okay, so we push two things on the top. Now, when we finish, this one should be 17. And this one should be 21. X0 plus 8. So top of the stack. VSP should be plus 16 because there should be two things on there still. Okay. Sorry about that. Should fail. Good, fails all over the place. All right. So notice it expects 17, it's got 21 and vice versa. So that's good. And then the stack is that one I may be off. The stack pointer should be, well, it starts off at VSP, add 1, it's at plus 8, add 2, it's at 16. Am I asserting something wrong there? That part should have passed, I thought. Load the VSP, load the push stack, but it's got to be that plus 16. Well, what is the difference? It's plus 8. How about we call swap? That's better. Okay. AB. So the first one is the first register, the second's the second. Okay, so X0 was A. Now it's getting pushed first. X1 was B. Now it's getting pushed first. All right, and put in main. No, not fair to print. Pop dot's not legal because dot's 0 at that point. Okay, but that's what we expect. Eventually we'll get a warning in there. Dupe we already had, but cab. Okay, so these are, I guess, they rotate lefts and rights in a way, but CAB pulls the bottom up to the top, and CBA does a swap and then a cab. And BAB just puts an extra one in there. Okay, alrighty, so CAB is a little different now. We got to do an extra word. Let's just put 9. Okay, so our stack is 21, 17, 9. And we're calling CAB. We load the test stack. Well, I think we're probably doing that the hard way too, right? I should be able to say data pop x0. Maybe do this first. Okay, x1 push test stack should be, well, 0, 8, 16, 24. All right, and this, we can just data pop x0 is the equivalent of that. X0 should be 21. X1 should be the old A. And then 9. No, am I getting it wrong, did I? Let's see. So it's 21, 17, 9. So when you use CAB, it should be 17, 9, 21. Sorry, so 21 should be on the top. 9 should be in the middle. And 17 on the bottom. Okay, what was B becomes C. Should fail. Good. Okay, yeah, they're unchanged in their order. All right. Well, I think we actually should have this. X0, X1, X2. So that's A, B, and C. We're going to push C, A, B. All right, this doesn't exist. Well, we'll use what we got, I guess. So this we got to push backwards. So if you data pop ABC and you data push ABC, I want them to be the same. Okay, I don't know if that's what I did back over here. A, B, C. Okay. Well, I think this should work. Go. Backslashes. And I think I'll define this third macro just to be kind of consistent. good. All right. And cab. Okay. That seems funny. 1, 2, 3, CAB. Let's do a pop dot. Came up to 1. Okay. Yeah, so Easter this weekend, I guess, right? Have a good Easter if that's what you do. Thanks for joining today. Let's see if I can make this. I expect 3 on top. Okay, something's off. We'll have to check it. I'll leave a note. But anyway, have a good weekend. I will see you Monday or some other time. Monday, 2 to 4:30 p.m. Uh, Eastern Time or 6 to 8:30 p.m. UTC. And I'm going to be out next Thursday next week, but I think we'll be back. We'll finish the last few operators and get if and while working. I think that'll be a good goal for those 3 days. All right, thank you, and have a good weekend. Bye bye.